Hello and welcome to part 1 of Make a Game in HTML. In this series we'll be making a game using HTML, CSS and TypeScript or JavaScript if that's your preference. We won't be using any gaming libraries or frameworks, but we will be using Aurelia 2 to help us with TypeScript and tooling setup. Aurelia 2 is currently still in pre-alpha, but it's already good enough for us to use. In this series, we won't focus on getting the game done as quickly as possible. Instead, we'll aim for good structure and sound principles through constant refactoring, so that we end up with something that you can take away into your other game or game-like projects. Okay, let's start. But before we dive into the code, let's use the magic of editing to take a look at what we will end up eventually after we've done with this part. Okay. Hello from the future. So you're now actually looking into my future. How cool is that? This is where we'll be in about, don't know how long it will take, but this is where we will end up today. Might not look that overwhelming, but hopefully we have sound structures in place. Okay, let's get back to now. We'll start with the default TypeScript project as it's created by the Aurelia 2 CLI. Now, if you prefer JavaScript, that's not an issue. Just pick that when you're going through the Aurelia 2 CLI. I've created a separate video that shows how to use the CLI options, and also the results, the folders and files that are scaffolded by it. And that's the basics for this project as well. So I put a link in the description to the separate video in case you want to dive in and get a little bit more information regarding that. For now, here we'll just continue by seeing if it builds. There you go. Hello world. Let's take a look at what we got. We got a main file, which is our bootstrap file that loads my app and starts it under Aurelia. And that in turn is 3 files. So let's, it's the CSS, it's HTML, and the view model. So here's the HTML, which is basically just a div with a message, an extrapolated variable, which is then found in the view model. It says hello world, and then we have styling of the div with a class message. So let's just verify by adding that very disturbingly missing comma, and save, and hello world. Okay, good. Let's get to it. We'll want an entity. Let's start by adding an entity. We'll make it a div and add a class. There you go. We need some styling. So we're going to want it to have inline block as well as position absolute. There you go. And we also want to add style to this. So yeah, sure, why not? But I was thinking, let's say 150, left 200. That's fine. And height. Let's do the same. Here you go. Save. And we of course need to show it somehow. So let's do border red so that we have something to look at. And there it is. Our first entity. Okay, so I split the CSS properties up in the way I did, because on the class, I've added those that will not change during runtime, and on the entity, on the element itself, I've gotten these that can change. So how would we change this? Well, since this is Aurelia, we can use extrapolation here. So we can do this. PX. In fact, no, let's just do this even. Okay. So this will now extrapolate, looking for a property of my app that has a property that's an object with these four properties in them. So let's do public entity and just do top. $150. Left with I should have copy pasted 250. There we go. Also, in addition, for this to always work for all browsers, this needs to be CSS instead of style. It's the Internet Explorer 11. And there it is. So now the idea is that if I change this, it'll move, and there it goes. Now I want a bit more structure here than just a plain JavaScript object, so I'm going to create a class for this. That has these properties. Go and instead use that as entity. Let's see how that works. We're still there. Let's move it. Let's move it back far to the right. And there you go. Now, top, left, width, and height works really well when we're working with CSS styles here. But when I'm within my game engine here, when I'm working with my game objects, my entities, I don't really want to work with these four properties. What I would prefer is to have a position, which is a vector, as well as a size that's also a vector. Let's create those. The file. So what's a vector? A vector is basically, and this is a 2D vector, so it's basically just two values. So I can do numbers. That's where it's supposed to be. So the public here as well. There we go. So that's a vector, two numbers, x and y in this case, if it's a 2D vector, which this is. So now I need to import it. And so that's what I want to work with. So I don't really want to work with these. So let's keep them for a bit, but let's put them away for now and just do. There you go. And if I now instead change this to right, those are the X. I need to switch these. And this will be size X and size Y. There you go. And then let's close. Then in my app, we need to fix so that we have better values here. Let's add for now and just do this entity and do 200, 150. No, sorry, I should say entity. Size. Somewhat smaller. CS. Yeah, that's exciting. And we need to do some import. So we get that in. Okay. Let's see. And we have that. Does look a bit small to me. Let's take a look by moving it down. Yep, that's down. But now what's happening is that I'm kind of exposing my internal stuff here, the position and the size, into the HTML stuff that wants left and top and width and so on. So what I want to do now is make some kind of interim context value here that I can push in between these two. So let's go back to the entity and say that we have a context that contain these. It should be public. That's how that works. That. There you go. We have our context. And this now means that what I want to be able to do here is have context and top. No, left, because I changed it. So that's what I want. There you go, and top. Of course, this doesn't exist yet. So what we'll need to do is, for now, add this. Let's do this in a constructor public. Doesn't have to be there, but let's, for now. So that'll change. Okay, so now we have the entity has a context, and that contains. What we also need to do now is that we need to push or translate or publish or send or whatever. I'm just going to call it draw because that's kind of standard. This will probably be changed later on, but for now, let's just call it draw. And this means that this context left is equal to this position x. So this is now top y with height. Of course, say x. There we go. Let's just try that. And this, of course, won't do anything. So now let's just make sure that it's not seen at all. Well, it's actually up here, which makes sense. Just a little dot, because in here we're setting these values, but we're actually not calling draw. So the values from the position and the size isn't updated into the context. But if I do this, we're back. So I can now move this up a bit just to make sure that things are the way they should, and it's up. Okay, so the next thing that I want to look into is that this position now of entity here, that represents the upper left corner here, x and left and y. I don't want that. I want the position to be the center of my entity. And I also know that I will eventually have to work with left, top, width, and height. That is the rectangles. I will also need to use both right and bottom as well. So what we're going to do is we're going to define another helper math class, which is called a rect. So we're going to save that. Start with that one. And the rect class, much like the entity, will also have a position and a size. And it will always be initiated with this, meaning that we could put them here instead. And from this, the rect now will define the different positions that we need. So it will define as getters, which would return, if we were zero based, it would return this position x, much as it does in the entity class right now. But we want to put, I want to put this in the middle. So how to do that? Well, we could do a public half, which is also another property. And when we're creating this, the new vector will do this half equals this size multiply by 0.5. Okay, so now we're lacking the multiply. So let's go in and add that. So we'll need a method here, public apply. That'll just take factor, which is a number, and it will return, should return a new vector with the modified value. In order to do that, let's create a clone that returns a vector that returns new vector this x and this y. So we have a clean way to get a copy of our vectors. So that means that we can now do changed, give me this clone, and then update this, changed x equals, and multiply this by, so we would do factor. But instead of doing that way, let's make it possible to update the current one as well, so that we could do this. If update this x factor this y factor, return this. Otherwise, we'll do this clone, multiply, factor, and then return that. So basically, if we call multiply with update, remove type annotation, sure, I could do that. If I call it with update, it will update the x itself and then return itself out. If I call it without update, then it prefers create a clone and then update that clone with the factor. That means that once I've done this, I can now create this half to be half of the size in x and y. So this now means that when I want position to represent the center of the rect, that means that I can, if I multiply x, sorry, I subtract x from the position, that's where I end up. So I can do the same with right, but instead I'll add it. And if I do top, it's the same thing. So that's y. There you go. And now bottom. Then we add it. So when I create the entity here, sorry, when I create the vector here, position and size, I want to, once I've done this, I want to do this entity rect equals new rect, this position and this size. That's what I want to do. So I need the entity to have the rect here as well, fabric rect, which is the rect. All right. There you go, and import it. Didn't I call it rect? Ah, yeah, that'll make it not work. So we've got the entity here, that, and the vector should be okay. And then let's go into my app, and we see that it's supposed to say rect. That needs to now be imported, and this should say entity. There you go. We haven't achieved much yet, but what we have achieved is that we can now do in entity, we can say that context here is rect left. rect top, rect width, rect height. That's what we want. So we need to add it to, these are easy enough. There we go. Let's see if this is still around. It is. Let's change this. Let's move it to the left. And there it goes. Okay, cool. Now this is a bit clunky. It feels like it doesn't really belong here. Well, it doesn't belong in this one, especially not this one. This is very much internal to the entity. So basically what it feels like is that I should be able to specify this. These are data within the entity. So if I have, let's create a way to define an entity by passing in a specification. That's an entity specification, which we don't have yet, which we will get. And that will do this. That makes more sense. So from, and we're encapsulating the rect here. That doesn't need to return anything. And we need to decide how this should look like. So one possible format that I think we're going to go for is that we kind of want to do this entity define and do without having to define vectors, instead just do two numbers. So we do 100 and 150 and do the same for size. So that's our specification, and that takes care of itself. So that's what we want to do. So we want to send in an array of two numbers here. So let's just have this. That's an interface, export interface, and have it take in position, which is an array of numbers, and size, which is also an array of numbers. That means when we get here, I can do, if I remove this temporarily, I can now do to see position and size as the options that I have. And that's nice. That also means I no longer need these here. So we can remove those for now. But of course we need to do that for now. What we want to do here, this isn't doing anything right now. So what we need to do here is fix this so that it's a spec position 0. The first and the second. Yeah. And we're doing the same here. That it should say size. Let's see if we're still in the game. seem to be. Let's try and change the value here and move that one 300. Boom. Okay. So nice. Now this kind of feels like it doesn't belong here at all. So let's make a that takes a spec. Just so we have that. It's a very small difference here for this now, but it feels more reasonable. There you go, and take entity specification, and it return the entity. We're just passing this along. Now we do create entity. Yep, that feels better. So let's see if we can just move that down so that we see everything is, yep, we're good. Now I do have certain issues with doing this in the app constructor. I normally want to keep things away from that. And we do have in Aurelia, we have a certain amount. There are a set of life cycle hooks. Let's do before attach. And before attach is a method that's a hook that's called when everything is prepared in the DOM. And actually, let's even do this. And what I want to do is I want to actually have this in main, which is the main game engine start thingy. That's where I think this belongs. Here's the start of everything. And this would then just do this main to keep this clean. Okay. So just before when we start the app here, and it prepares the DOM, and just before these are added to the actual document, this hook is called before attach, and that triggers main, and main creates the entity here, which in turn results in this getting the right values. Let's see if that works, and refresh. Yeah, that was quick. Yeah, so that's a bit better structurally, and keep this one clean for us. So we have main, we have that create entity. Okay, so what more can we do? We can add let's say we want to move this entity. So what we would do then is that we create, we could do a set timeout. We could do a set interval as well that triggers every second. We'll do this entity position X. Yeah, sure, why not? Now once we've done this, since we updated this, we also need to draw call draw here in order to get this sent to the context. See if this works. There you go. Every second we're moving it 10 to the right. Now set interval is a bit messy. And it's a bit uncontrolled. Aurelia, normally we wouldn't do that. We would use something called request animation frame. That's better and more stable. But Aurelia provides something that's even more stable for us, and that's comes with a scheduler, a lifecycle scheduler that I could import from Aurelia, and and use dependency injection private. That can be there. To have a scheduler here, this scheduler, I want to queue the render task, queue render task, and pass the method, that's the same. And also I need to say that it's called persistent, I think. Yes, that this should be true. So this means that depending on my update speed in the browser, this is tied to the update speed in the browser. It will call this and this is every 17th millisecond. It will call this, the method I provided here. And since I said persistent, this will be recurring. So this is basically set interval with 16.6 milliseconds as the second parameter, but it's tied and in sync with browser updates. It's a somewhat better version of request animation frame. Let's see if this works. Well, that went away quickly. And that's, and I'll tell you why. Because this is now called a lot more often than the other one. In fact, this is called, I could pass in a delta time here, which is a number. And to see, so basically what's happening is this is now called 60 times per second, and that made it that's making it fly away. Yeah. So what I wanted this to be 10 steps per second, 10 pixels. I need to involve delta time, and delta time is the amount of time it took since it is since the last time this method was called. And that means that, and it's in milliseconds. So this could be, for example, 16, if it's been 16 milliseconds. So what I want to do is I want to, first of all, turn this into seconds by dividing it by milliseconds by 1,000. And then I want to multiply this with the delta time, so that it's moving this part of the step every time it's called. And we can now see that it's moving 10 steps a second, but it's not as jerky as it was before. Well, it is now, but it's not 10, 10, 10. It's parts of 10. (16 times a second). Okay, so this is a bit ugly to have in this, because basically what this is our update method. This updates the position of the entity. In this case, that's what's going to happen with its position. So what I want to do is that I'm going to move this into the entity and say update and have that. So, and now also going to do, let's say instead of having this, let's also create, for consistency, let's create an update here as well. In this case though, we will keep it as a property with a fat arrow method so that we can do this update. We've now achieved the same thing. Let's return void. Void sensitive. So, and instead of doing the position change here, we're going to let call update with delta time, the now divided delta time. So that's done once. So we're fixing that, and then we're calling update in the entity, meaning that this will call queue_render task. We'll make sure that update is called once every, well, 16 times a second, with the amount of milliseconds since last time was called. Let's put that, turn that into a second to get a partial, so 0.0016, and then pass that into the update of the entity. And that method no longer needs to split this. And what this does is that it updates its position. And it shouldn't call draw. It should just update the position. Need to add a void there to get rid of it. There you go. Is this now working? Yes, it is. So if I'm fixing, let's, this is needlessly ugly. So let's add another property here for the, doesn't like that. So let's change that. Okay. So let's add a velocity number, which is also a vector. This is how if at all I'm moving right now. And that means that if this is a vector value, I could do this position, add this velocity, and update. So my position, true. So if I have a velocity that's a vector, I need to go into vector and fix the add method. Put that. And this takes a change delta, which is a vector. Update. X, delta, Y. Add delta. So just like with multiply, we're checking if the update is true or false. If it's false, then we're cloning it and updating the clone. If it's true, we're updating it immediately. And this means that when we want to add this, the velocity to the position, we'll just call add and set this to true. This this will now not properly work. And let's see if you can figure out why. I need to go into, first of all, I need to go into this, the define here and say velocity. No, that was hard apparently. Just going to have that separate. Oh, have that separate from the rect. And then I need to set a velocity here because that's mandatory. And we'll just do 10, 15. Let's see if we can. I'll refresh. Boom. And it's quick again. Why is it quick again? Because when we're doing the update, we're just adding the velocity the way it is. We're not considering delta time. So what we need to do then is multiply this with delta time. And since I'm not passing in update, this velocity multiplied with delta time will give me a clone of the velocity multiplied with delta time, which in turn will be used to update the position. So we're keeping the velocity value intact, but we're changing the position value. And here we have the proper movement. Really slow. Let's just update this to make it somewhat more. Keep us from snoring. There we go. Okay, so what can we do more with this? So let's add some randomness to the movement here. This is probably not. Yeah, let's add a function called, this is a helper function, min number. This is return math random. So I'm going to make a method that that takes an interval in and returns a random number within that interval. There we go. Oh, I need to math floor this. So if I pass in 1 to 10 here, I'll get a random value from 1 to 10 as an integer as well. So now I could do random int yeah, that's fine. And this now, whenever I'm refreshing, is giving me different directions. Yeah. So what I can do now is in update, we can do the movement, we can do the draw, and then we can, if random int 1 to 100 into 10 just to get an effect. So if that is 1, which is a 1 in 10 chance, then this is a bit stupid, but that's fine. Random int. (15 to 75). Now let's actually let's do. Of course, we need to do this so that it can go either way. Now it's going to jump around a lot. Off it went. Let's start it a bit further down. And in. You can see that it's moving around because every 1 in 10 this update it is randomly changing X. So let's also randomly change Y. There you go. Maybe it's a bit rushed. So if I do this, set this to 60, since this is called 60 times a second, statistically this will now change direction every second, give or take. Okay, so this is, I don't know, nice and all that. This should probably be, this should of course not be here. It should be an entity, but we're not. Okay, yeah, this bothers me. So we're just going to do public randomized direction velocity. This will do this will make the change, and this will do it. There you go. Okay, so that didn't, oh, right, because I don't have that. So we need to move, oh, that's disturbing, but I can actually import it here, I think. Import. If I export it. This is, yeah, this is bad. So let's do. Just move this out here. Where it should have been from the beginning. See how much time we lost. There you go. And so we're good there, and this probably needs to import it as well. And now we're good. And there is very little change. Okay. So that happened. That's fine. This is looking a bit boring though. Just a red square. So let's turn it into something a little more visually pleasing. And then I think we'll end it there. So I'm going to go in here to my project and create, right, I need to not add a folder called assets. And, oh, let's do this. Yeah, that's nice. Yeah, sure. And the Aurelia icon, that's good. And then for the entity here, let's do a background image. Is that right? I think so. Possibly. And there you go. A lot nicer. And now we can also go into the CSS here and temporarily remove the border. Sure, let's make it a bit bigger. There you go. So let's recap. We have our main app here that basically just injects a scheduler and runs main, which create our entity and draw it the first time. Shouldn't really be necessary, but let's. And then we add a queue-render task that calls update 60 times per second, passing in how long it's been since the last time was called, return that in millisecond, turns that in seconds, update the entity and draw it, and then if a 1 in 60 chance, then randomize the velocity of the entity, and we have a helper create entity. And basically our entity has a specification. We have a context which is used for transfer into to match better with the display, the view of the browser. And we have our internal properties that we're working with, that we like to work with. And then our definition, the update that happens 60 times per second, and the draw that comes after the update that also happens 60 times per second. And this happens randomly, that we update this. And we have this, we don't need that anymore. And then we have a rect and a vector that are helper classes for us. And that's it. And that results in this, which is, and it's gone. So there it is. And I think that's where we'll leave off today. So this is the part that will be edited into the beginning. Let's refresh that and have it more centered. There it is. This is what we see. Hello from the future. Yeah. Okay. So in the next one, we'll look at preventing this from happening, I think, to define this within a world, and possibly also add more than one entity. We'll see. So thank you for sticking around. Please leave a comment, and yeah, see you next time. Bye bye.